video is about solving simultaneous equations. This is part 1, where we will solve them using the substitution method, and part 2 will be about solving them using the elimination method. We're going to do a quick introduction to simultaneous equation just to understand what they are. So simultaneous equations relates to two equations or a system of equations, and we have two unknowns in this case, so x and y. Now I cannot find the value of x and y using just one linear equation. I need another one in order to establish the relationship between them. So what this system is telling me is that there's a specific x and there's a specific y that will make the first statement true and then second statement true. Graphically, this can be represented by showing the intersection of these two lines. So what I'm using here is Geogebra. Geogebra is a free website. Feel free to use it to easily understand and check what the graphs and linear equations are doing. So I've already plugged in my two equations and I got these two linear lines. And if you notice, they will always meet at one point of intersection. And this will be your solution to the equation. So when you solve simultaneous equations, you find the value of x and y. This is what they represent. They represent the point of intersection between the two lines. Geogebra immediately gives you the answer, so it tells me that x should be equal to -1 and y should be equal to 3. So it's a good tool to use in case you want to check your answer or to understand how the equations are. This is just a quick introduction to it, but now we can start solving the simultaneous equation. So the first step is through substitution. Through substitution and elimination, our goal will always be to reduce from two unknowns to only one unknown, and that will make the equations easier to solve. So with substitution, I want to represent one letter using another, and this can be done with any letter and using any equation in the beginning. So I would recommend you, once you understand the process of this video, you go back to the beginning and try to do a substitution using a different equation or do a substitution using a different letter. It's always good practice to try out different methods. So for this equation, you always start labeling your simultaneous equation, equation 1 or 2, and what I want to do is pick on equation 2 because it seems the easier to deal with. So I'm going to take equation 2 and I want to represent x using y. So my elimination will be through x. So I have my equation x plus 2y equals to 5. And what I want to get to is x equals to something. Okay, I want to represent x using something else. This is quite easy. It's like solving linear equations. So what you do is you want to get rid of the 2y. The opposite of positive 2y is negative 2y. I'm using the balancing method in this video. And on the left-hand side, this cancels out, so I'm left with x. And then on the right-hand side, I'm left with 5 minus 2y. So what I'm doing right now is I'm representing my x using y, which means that I can easily replace any x that I see in my simultaneous equation with this expression. Okay, try to understand that now that I've written them as equals, x is exactly equal to 5 minus 2y. So I can use either representation for x. So I can either write x whenever I want x, or I could write 5 minus 2y whenever I want x. So since we used equation 2, I'm going to refer to equation 1 now. So equation 1 has 2x plus 3y equals to 7. Now, as we said, we want to reduce the number of unknowns we have, and this time we can reduce it through x. So as we said, x can be represented by 5 minus 2y. So I'm going to do just that. So instead of writing x, I'm going to write 2 and then I'm going to plug in 5 minus 2y. Because we said that this x is exactly equal to 5 minus 2y. We've established that already. So I am allowed to do this substitution, hence the name of the method. And then I'm going to continue similarly. Then I'm going to expand and simplify. So 2 times 5, that's 10. 2 times negative 2y, that's negative 4y, plus 3y equals to 7. And then I'm going to simplify, so remember to take the sign in front of your term. So I have a negative 4y plus 3y. I'm left with 10 minus y equals to 7. And then you can solve this in any method you want, but I will subtract 10 from both sides. I'm left with negative y equals to negative 3. And then I don't like this negative, so I'm going to divide both sides by negative 1, which will give me y equals to 3. Now I could have avoided this divide by negative 1 step by actually adding y to both sides, or if you're using the move to the other side method, you're moving negative y to the other side. However, do be comfortable with these type of methods as well, as it will make your algebra skills much better. So now that I've used the substitution method, notice that when we substituted the 5 minus 2y instead of the x, we completely reduced our expression from 2 unknowns to 1 unknown only. So we were able to solve it easily because we do know how to solve expressions with 1 unknown. So at the end, we're left with y equals to 3. Well, now that I know the value of 1 unknown, I can easily find the value of the other. So the best step to do right now is to use our substitution. You can also substitute your y into any of these equations, either would work. However, we've already established that x is equal to 5 minus 2y, and we know that y is equal to 3, so 5 minus 2 multiplied by 3, and then reducing it will give us negative 1. So x is equal to, y is equal to 3 and x equals to negative 1. Always lay out your answer in the end, which confirms what the graph told us initially, which is that the x coordinate is negative 1 and the y coordinate is 3. Go to the next part of this video in order to know how to solve this simultaneous equation using the elimination method.